Hello, welcome to my channel. I am Ameya and we are discussing about Routh stability criteria in control systems. In previous video, we talked about stability and the array Routh stability array and how we can determine stable or unstable system depending upon that array. So let us try to solve one problem by which you can determine the stability of the system. So problem for this, a directly characteristic equation is given. Delta S is equal to S raised to 6. Just a second, I will just increase the thickness. Yeah, so delta S is equal to S raised to 6 plus 4S raised to 5 plus 3S raised to 4 plus 2S cube plus S square plus 4S plus 4. That is what the characteristic equation is given. Then to start with Routh's array, we will go with S raised to 6, that is the first term which we have, and you can start with the first coefficient, that is 1, and then you can take the alternate coefficient 1, 3, 1, 4. Okay, so I am just keeping some distance so that I can easily solve this Routh's array right below everything. And then I am doing the second line, second row, that is S raised to 4, and I'm just changing a color. You can start with 4 and the alternate coefficient 4, 2, 4, 0. So I'm giving 4, 2, 4 and 0. The next row will be again S raised to 4, and for this row what you will do is you will try to find determinant. Okay, and what are the values for that determinant? Let me just zoom in. What are the values of those determinant? 1, 4, 3, 2, divide by 4. That is what your value of this row and column element will be. What about the second one? It will be again minus. This you have to skip. This will not be there. So 1, 4 and 1, 4 upon 4. What about third one? You have to skip this and also this. First row will be always same. So 1, 4, 4, 0 upon 4. So this term is always there and first column is always there. So this is how you will get the answers for these determinants will be, this will be 4 into 3 minus, sorry, 4 into, yeah, 4 into 3 minus 2 into 1, that is 10 upon 4. So it will be 5 by 4. So this will be 5 by 2, sorry, not 4, 5 by 2. This will be 0. 1, 4, 1, 4 will get cancelled, and the last term is 4 because this will be 0. 4 into 4 divided by 4. Okay, now we will use these terms as b1, b2 and b3. Okay, just remember in the previous video we have calculated this b1, b2, b3, and then you can use these terms for the further values. Now continuing with this row, you can go with s raised to 3. Again s raised to 3 will be combination of this into this, that is 5 minus 4 divided by 5 by 2. Okay, so it will be, the final answer will be, I will just write determinant for this case and then we will continue with direct values. This will be 4 upon 5 by 2 second term. The next term will be 2 and 0. upon 5 by 2. So 5 by 2 into 2 divided by 5 by 2, the value will be 2. Similarly, if you try to solve this, you will get value to be minus 12 by 5, and again this is 0. So this should keep on decreasing. Okay, so just avoid to write this 0. This is going to be 0, and then you can go with s raised to 2. S raised to 2 you will get here 3, here you will get 4, s raised to 1, which is minus 76 divided by 15 because of this, and then there is a 0, and s raised to 0 will be again 4. Okay, I am just increasing this line. Yeah, so this is how your Routh's array will complete. Okay, you have to start with s raised to 6 and you have to end with s raised to 0. So total there will be, starting with 6, s raised to 0, so total there will be 7 rows, and you will get the reducing matrix. This should get reduced to 1. Now what about the stability? Let us write the terms for first column. I have 1 in the first row, I have 4 in the second row, I have 5 by 2 in third, I have 2 in fourth row, 3 in fifth, minus 76 by 15, and then 4. So there is sign change, right? So this is what a sign change is. Here is the sign change. So system is definitely going to be unstable. So first answer is system is unstable. That is your first answer because of sign change. The second thing which you can find out from this is how many number of sign changes. Okay, so first if you check, there is a sign change from this positive to negative, and then there is one more sign change, that is negative to positive. So you got 1 and 2. So two sign changes. This number of sign change will give you number of poles on right hand side of your S plane. Okay, we have seen S plane in the previous videos. So whatever comes on the right hand side, that is becoming unstable. Okay, so that's why this system is definitely going to be unstable. And the second point is giving how many number of poles on right hand side. So this is how you can predict from this equation that system is going to be unstable, and there are two sign changes, that means two poles. This is not, no, this is two poles, sorry, this is two poles on right hand side of your S plane. So you need to find two answers for your Routh criteria. One is about the stability and one is about the number of poles on the right hand side if your system is going to be unstable. If it is stable, all poles or zeros will be on left hand side and system is going to be stable. So this is how you basically solve the Routh criteria. If you like this content, do subscribe my channel, share with your friends, and check out my playlist on my channel for control systems, mechanical measurements, and automation. Thank you for joining.